Welcome to Saucy Math. This video is going to be about rational expressions when you're adding and subtracting them. So I'm basically just going to do one example of subtracting rational expressions, and the adding is basically the same process with just one little difference in there, which I'll get to when we get to that point. So rational expressions, first of all, what they are expressions that are written like fractions, but they're not just simple fractions, like 1/2 minus 1/3. Rational expressions are, fractions that have algebraic expressions built in. So like x over x squared plus x minus 2 over x squared minus 5x plus 4. All right, but still, what we're doing here is we are subtracting two fractions, right? And if you remember the rules of dealing with fractions, when you subtract two fractions, you have to start by finding a common denominator for those two fractions. And if you look at our two denominators now, they are not common, right? We have x squared plus x minus 2. This one's x squared minus 5x plus 4. Those denominators don't match, which means we have to do a little bit of work in order to find that common denominator in order to be able to actually combine these two fractions together. Right, so that's most of the work involved in a problem like this, is figuring out what that common denominator is and then getting those two fractions to match up. All right, now the way we find a common denominator for a rational expression like this is by factoring the denominators that we have. All right, so I'll start with this first one, x over, now instead of x squared plus x minus 2, I'm going to factor that denominator. All right, so x squared plus x minus 2 is equal to x plus 2 times x minus 1. Right, and I'm not going to spend a lot of time explaining how I factor that. If you're not sure about the factoring part, I made quite a few videos about factoring, so you can check those out and get a little help with how to factor something like this. Because for pretty much any one of these problems where you're adding or subtracting rational expressions, or also the ones where you're multiplying or dividing rational expressions, factoring is a key part of doing that problem. All right, so if you're not good with the factoring, check out some of those videos to make sure you understand how to do that. All right, so our next fraction now, 2 over x squared minus 5x plus 4. If we factor the x squared minus 5x plus 4, that factors into x minus 4 times x minus 1. All right, so we have factored our two expressions, and now we can compare our denominators. Right, this denominator has an x plus 2 times an x minus 1. This one has an x minus 4 times an x minus 1. All right, so when we want to put together our common denominator, basically we have to represent all of the factors that we have in the denominators of all of our terms that we have as part of this problem. All right, so what our common denominator is going to be, if I just kind of abbreviate this over here, it's going to be basically one of each factor that we have. So our first denominator starts with an x minus 2, with an x plus 2. So our first factor of our common denominator is going to be x plus 2. Then we have an x minus 1. All right, so then we have a factor of x minus 1 in our common denominator. Our other fraction has a factor of an x minus 4. So that's going to be part of our common denominator. And then this one also has an x minus 1, but we already have that x minus 1 included because that's a common factor that's shared with our denominator over here. All right, so our common denominator is going to be x plus 2 times x minus 1 times x minus 4. All right, so that's how you determine your common denominator for any one of these problems where you have to add or subtract your rational expressions. And you do it the same way, whether it's addition or subtraction, that doesn't matter. Multiplication or division, you have to do something totally different, and I have another video on how to cover those types of problems. But adding or subtracting, you always start the same way. You factor your denominators, and then you basically take one of each factor to figure out what your common denominator is going to be. All right, so what we need to do now is make sure both of our fractions have that common denominator. All right, so let me kind of skip down here a little bit, just so we have some space. So our original fraction, the first one, had factors of x plus 2 and x minus 1. All right, so we already had those factors, but our common denominator has those factors and an x minus 4 factor. So I need to multiply that x minus 4 factor into the denominator of that first fraction, but I can't just put that into the denominator. I also have to multiply it to the numerator. Right, so basically I'm taking that first fraction and multiplying by x minus 4 over x minus 4, which anything over itself is equal to 1. Right, so I'm basically multiplying that fraction times 1, which is why I'm able to do that, right? Because when you multiply something times 1, you don't change the value of what it is. Right, so whatever factor is missing here, I have to multiply that missing factor, the x minus 4 in this case, on the top and the bottom. All right, and then I have to do the similar thing for that second fraction. All right, so the 2 on top, and then this fraction originally had the x minus 4 and the x minus 1 as its denominator. All right, now our common denominator has the x minus 1, the x minus 4, but it's missing this time the x plus 2. So I have to multiply that missing factor, the x plus 2, in the numerator and the denominator of that second fraction. Okay, and once again, it's whatever factor is missing, you multiply that on the top and the bottom, because really you're just multiplying it by 1. You're not changing the value of what it is you're working with. All right, so now you see both of my fractions have a factor of x plus 2, they both have a factor of x minus 1, and they both have a factor of x minus 4. Right? They're not written in the same order, and if you're really anal about that type of thing, you can write them in the same order if you want to. It doesn't really matter, but if you feel more comfortable doing that, by all means go ahead and put them in the same order. What we can do now, since our two fractions have the same denominator, right? They have the same factors in the denominators, we can combine them together. Right? So I'm going to make just one fraction with the denominator of x plus 2, x minus 1, x minus 4. And then I'm going to take the numerator or the two numerators, and I'm going to do whatever operation we have, which here is subtraction, right? And this is where the difference between addition and subtraction of these rational expressions comes into play, right? If this was a plus here, I would do x times x minus 4, right? What I have here is minus 2, so it's minus 2 times x plus 2, right? If that was a plus, I would write plus 2 times x plus 2. Right, which seems like a pretty obvious thing, and that's really the only difference between adding and subtracting the rational expressions. Yeah, so once we do that now, we can combine this stuff together. The key thing is, if it's subtraction, and this is why I chose to do a subtraction problem instead of addition, if it's subtraction, you just have to make sure that that negative goes to this entire second expression here. So it's like you have to distribute that negative all the way through, which we'll do down here when we multiply that negative 2 through this parentheses. That negative will go with the 2, so we make sure we distribute that subtraction all the way through our second fraction. Right? That's the key difference between addition and subtraction, is making sure you distribute that negative for subtraction. Right? And what we need to do now is basically just simplify what we have in our numerator and combine like terms together. All right, so I'm going to distribute the x into that first parentheses, so it's going to be x squared minus 4x. Now I'm going to distribute the negative 2 into the second parentheses. So it's going to be minus 2x and then minus 4. All right, all of that over that same common denominator that we found a couple minutes ago. All right, so that's our expression now. We've combined our two fractions together, and now, like I said, it's just combining the like terms, which is going to give us, let's see, we have the x squared, we have the minus 4x minus 2x, so that's minus 6x, and then minus 4, all over x plus 2 times x minus 1 times x minus 4. Right, now, generally when you do these problems, you don't have to multiply out all that stuff in the denominator. That would make this a way more difficult thing to do. And so that's one reason we don't want to do it, is just to be lazy. We don't want to have to do all that extra work. Another reason we don't want to multiply all that stuff out is because sometimes what we end up with in our numerator can be factored. Right? In this case, x squared minus 6x minus 4, we can't factor that because we won't be able to find two numbers that multiply to negative 4 and add up to negative 6. So this one can't be factored. But if it was one where we could factor it, sometimes when we factor this, something might match up with what we have in the denominator, and we could cancel out some of our factors, right? Which we wouldn't be able to do that if we had multiplied all this stuff out. Right, so that's the real reason why we don't want to multiply out all that stuff in the denominator. Right, we'll just leave it as, the factors x plus 2 times x minus 1 times x minus 4. Right, and if your teacher does tell you that you need to multiply all this stuff out to write it as like a long polynomial, then I would wait until your teacher turns around and like poop in his coffee or something, because that's just a horrible thing to make you do. All right, so that is an example of adding and subtracting, or in this case, subtracting rational expressions. Like I said, adding, you're basically doing the same steps. The only difference is when you actually come to doing the adding or subtracting, you add or subtract, right? That's an obvious difference between the two. But the process to do those is exactly the same. And check out my other video that I made on multiplying or dividing rational expressions, because it's similar, but it's a completely different process, right? So you have to make sure you know how to do those types of problems as well.